Welcome everyone to this ITQ Lightboard session. I'm Carlos Mestre Pino, one of the cloud native consultants in the Dutch team, and I'm joined today by Kushtrim, cloud native consultant in the German team. How are you doing today, Kushtrim?
Doing great.
Well, I think today you're going to be talking to us about GitOps and ArgoCD, right?
Yeah, Carlos, you're right. I'm going to talk about GitOps and how this is implemented in field by using ArgoCD. So first, what is GitOps?
Yeah.
GitOps, it's a development methodology which is used by developers, but also from infrastructure people to deploy application in Kubernetes infrastructure.
Yeah.
From the name, you can see it's GitOps, so everything is based in Git.
Yeah.
GitOps consists of four principles or commandments, which are basically used to define if the deployment way is pure GitOps or not. It starts with declarative. What this means is that all the source code and also configuration of the application should be hosted on Git in a declarative way. And because it's in Git, it's nice and it must be versioned in order to be a GitOps, so it's versioned.
Yeah.
And the other thing which is really important is that all the configuration which is currently being hosted, stored on Git, it must be pulled automatically. Okay. So you don't need to trigger something to deploy the app, but this should be pulled automatically from the infrastructure where the app is stored. Okay. So it must be pulled automatically. And the last thing, which is the most important thing and what makes GitOps special, is everything is reconciled. So it's a continuous reconciliation.
Yeah.
What this means is that whatever changes on the Git side, so whatever changes in the code, it's applied, but also vice versa. If we change something on the infrastructure side, the difference is pulled from the Git and the the state is reconciled. So basically, it returns to the proper and the defined status.
Yeah. And this is the CD part of it, right? Like continuously deploying those changes.
Yeah, this is a but what is makes the difference from the traditional continuous deployment that we were already doing is this, that it's not that when you push a new code or something, this is deployed, but even it continuously loops through the infrastructure and check if what we wanted to be deployed, let's say in the morning, it's already there and it didn't change in the meantime.
Yeah. And
the best part of it is that this is based on the technologies or the way how we worked before. So it uses it's not some new things that is added, but it's based on the methodologies that we used before. For example, every developer used Git workflows.
So GitOps more about really standardizing the practices which are already there, right? We're not trying to impose a new way of working to the developers, right? It's just kind of adapting to the way that they already work.
Yeah, that's correct. So basically it's adapting for what infrastructure guys used to do and also what developers used to do. So it's just putting these two worlds together and using the existing tools, but in a specified methodology. So it's used Git workflow, infrastructure as a code, so YAML files, continuous CD, tracing, observability, and also immutable servers.
Okay.
And you might be thinking how this is implemented. Like this is a practice, how we use it.
Yeah, which kind of software, which kind of components? Well, you mentioned ArgoCD, right?
Yeah. So it's ArgoCD, one of them. It's Flux, and there are some other tools which are doing this now. Yeah. But ArgoCD is a tool which is it has a really great community and is being used by a lot of people. So you have a lot of best practice out there that you can find. And ArgoCD is a component which is installed on top of Kubernetes. You can use Helm chart, YAML, or CLI to install ArgoCD in a Kubernetes cluster. and it doesn't matter what kind of Kubernetes cluster are you using, and it has different components like server, API, repository, and also app controller.
Okay.
All these services or all these components have different roles. For example, server does the deployment process of the application to the Kubernetes cluster. API is a set of RESTful APIs which is used to call the server.
So for you to interact with the server, yeah.
Repo, which is used to connect to different kind of repo, which might be like GitHub or Bitbucket or GitLab, as long as
it uses the Git protocol.
As it's a Git protocol, then you can use that. So it doesn't matter, and you store the code or the configuration there. And also there is another component which is CLI, which is used to call Argo server when you want to deploy, delete, or check the application status.
So
one thing that I forgot to mention is application controller, which is basically the most important part of the Argo.
Yeah.
And the application controller does continuously monitoring of the state, which is in Kubernetes clusters.
Okay.
And it checks if the app there is in the desired state on the Git, then it's okay, it just continues. But if the app has a drift or is different, it calls other component and asks them to redeploy and check if the status is correct. And good thing about Argo is that it's not dependent on any type of cloud environment or Kubernetes environment. It can deploy anywhere. For example, in TKG cluster, in AKS, EKS, and also pure Kubernetes.
And it's also open source, of course. So.
Yeah, it's open source. So, as I said, the most important part of this is the reconciliation loop. Yeah. So basically, we have the desired state, which is on Git. And we have the current state, which is on Kubernetes cluster. And what this Argo does, it continually observes if the current state is as desired state.
So it's comparing them,
And then it reconciles.
Okay.
So this is the whole structure. Now, this is more in, let's say, infrastructure side, but we want to know how developers, how this would be in a real case,
if
right?
I was to want to deploy an application now with ArgoCD, how would that kind of workflow would be?
Yeah. So you're a developer, you're doing an app, and you want to deploy that app on TKG cluster. And first thing you would do, you would commit that to Git repo.
Okay.
So you have the commit. And what this usually would trigger a build, right? In CI side, so it doesn't matter if it's any Jenkins or GitHub Actions or and it doesn't matter that CI. That build will generate the package, but also it will trigger a build image. So you would build an image, container image, and then push that image to a container repo like, for example, Docker Hub or Harbor.
Yeah, Harbor, registry.
This is the basically the build side or CI side. So we have now an image with a specified tag. Now we want to deploy that tag, right? So in order to do that, it creates a PR on the config repo, which is stored on Git. And that PR sometimes might be approved automatically. Depends on the environment, most of the cases. Sometimes manually, it runs some tests, and then someone manually approves the PR. And after it approves the PR, the changes are merged to a specified branch. Usually, would be the best practice is to be the main branch. And then, when the main branch, the code is in the main branch, then Argo, which is here, would pull Basically, it pulls the changes,
Yep.
and then it applies in Kubernetes cluster. And we have the state.
And this is constantly happening, right? That's kind of like the loop that you were explaining down here.
This pull, it's constantly happening, so it can be defined. You can also trigger if you want from Git, but the best practice is to pull always, because if you want to trigger from Git, then you have to give Git access to the ArgoCD cluster, which would mean security issues. But the other way around is Argo will always pull the Git repo every 3 minutes or 5 minutes. It doesn't matter how you specify it, and then it pulls the code, and then it applies to Kubernetes cluster. If something fails or goes wrong, Argo sends alerts to the people who, the ops team or dev team, and also it keeps the current state that was before that. So it switches back.
And perhaps on another note, I wanted to go back a little bit with this infrastructure as code part that you had, because we're talking in here about deploying applications, but you could have some Terraform defined, and you could actually reconcile that infrastructure with ArgoCD.
Yeah.
Is that correct?
You can. This is the great thing about GitOps, because you can use different kind of tools. You can use Terraform. You can use pure YAML file. Use different operators like crossplane to create the whole infrastructure. So basically, you keep everything in Git infrastructure, code. And developers' infrastructure can see what is going on, what is being deployed, and then it's deployed to Kubernetes using Terraform or Crossplane or pure YAML.
Yeah. Okay.
And last thing, benefits. So as you might see, it's really fast. You just do a commit and it deploys. It has a really nice observability, so developers see what is being deployed, where it's being deployed, going through the preferred tool, which is Git.
Yeah.
And also it has auditing, so if you make a commit or a different change or something, it's always there. And the best part, you can go back. So you deploy something wrong, you just roll back and rebranch and deploy, and you deploy the previous.
Yeah, isn't that nice? I think that's quite a way to kind of carry on your, operations, when it comes to deploying those applications into Kubernetes. Well, thank you everyone for joining this Lightboard session. And well, for more information on ArgoCD, you can always contact ITQ. Thanks everyone.
Thanks everyone.